Cause it's Ninja Hana Ninja. And first and foremost, actually, before I reveal this video to you, uh, the only comment I left, it has, let's see, it's called Floathead Physics 4864. Oh shit, it's a lot more subscribers than I thought. Basically, it has 39,000 views up 11 hours ago. Uh, Basically, 500,000 subscribers. So, anyways, bam. I never understood why matter curves is space time until now. And my one only comment was time isn't real. So based on that,
Newton says gravity is a physical force pulling on that satellite.
okay,
But Einstein says, gravity isn't a physical force at all. It's just an artifact of Earth curving the spacetime around it.
okay. So all you did was you said it's not called A, it's called B, but you're still saying that it does one. Okay, so it doesn't matter.
And that satellite, it's moving straight through that curved spacetime. But my question is,
Okay, again,
why?
why what?
Why did Einstein and humanity conclude that? I mean, it's
Conclude what?
cool to repeat quotes like matter tells spacetime how to curve and spacetime tells matter how to move. But science is not about understanding facts, it's about sharpening our thinking. So, my
Right, and it's not only about that, but it's also about me taking my idea in my head and putting it into your head. It's so that I can take my torch of leadership, because I'm alpha of alphas, king of kings, and I can go, I'm old, you take over, I'm gonna die, you take over, keep the tradition going while I'm gone. Basically, that's reality we all make one day. That's what the point of all that is for. People forgot that and they think, oh, it's all about getting in the books. It's all about being remembered forever. No, that's what these little baby dicks make it out to be because they sucked and they're insignificant and they don't know what an alpha is like and what it's like to be an actual alpha. They faked it and they want to be remembered because they realized, oh, all I did was carry water for some guy before me and stole his ideas, but no one's gonna remember me for me because there's nothing I'm doing that's original, that's my own, that I actually invented. Because I'm a thief and I steal credit, and that's literally what our generation is full of. Is just reporters. Basically, it's just people that watch a report of a report and make a report on the report. Basically, no one's out there really mixing it up. Like I want to be a front runner, but I can't be a front runner because I look and there's a bunch of fucking big gammas take up the whole highway pretending to be something they're not. And so yeah.
question was, how can I intuitively go from Newton's model to Einstein's idea of curved spacetime?
They're the same thing.
What is the exact step by step thought process?
They're the same thing. It doesn't matter. Who cares?
And I think I finally understand it, and I'm super excited to share that with you.
Cool. Go ahead.
So, in this video, we're going to
Doesn't matter, but go ahead.
start by pretending we don't know anything about space-time curvature. And
Well, first and foremost, you don't know anything about that because that's not a thing. It's something someone invented as it's like learning a language or learning math or learning a subject. Like even psychology, like in psychology, we have a roadmap of events in life. Like for example, you buy a car insurance. If you're 18, your premiums are way higher than if you're 40 because they know at 18 you're more hot-headed than when you're at 40. Basically, they know that, or at least not really they know that. But if you are what's it called, a meta head, basically, they can assume that. Like me myself, I'm an old gentleman, but I'm just as hot headed as I was as an 18-year-old because I'm an uncontained, uncontrolled alpha, and I will keep fucking up fucking China shops or little coffee shops, little coffee cups and shit. Like they're just saying it's like a bullet in the china shop. Basically, that's me. Basically, right? And just because there's regulations doesn't mean shit to me. And again, as an 18-year-old, I drive just fine. I'm very calm, very logical, I'm very methodical and precise in my measurement and my movement or whatever, but I don't believe in other people's bullshit. But anyways, again, alpha, real deal, main thing. Not trying to fake it. I had bitches, I had this, I had that. I grew up challenging everybody. I know what fucking it is. Anyways, and I know what fakers do and how resentful they can be and why they invent this bullshit. And they try to say, "Oh, this is how the world works. The universe is speaking to us." No, that's your language. You invented it for it, and you expect us to learn it because you're full of shit. Anyways,
By the end of it, hopefully, we would have rediscovered all of it intuitively. So if you're ready for this, let's begin.
try me, bitch.
We've had theories for why
Nope, you're wrong. Okay.
things fall down for thousands of years. For example, Aristotle believed everything naturally tends to move towards the center of the universe, which is obviously the earth. Meanwhile, Brahmagupta in ancient India used the term Gurutvakarsanam, a Sanskrit word meaning attraction due to heaviness. That's pretty cool if you ask me. So these ideas were pretty impressive for their time, but they were still pretty vague and local. For a long time, we believed the laws of the earth were completely separate from those that govern the heavens. But starting in the 1500s, all of that changed very quickly. Copernicus helped replace the earth with the sun at the center. Galileo made breakthroughs in inertia. Starting in the 1500s, all of that changed very quickly. Copernicus helped.
I don't think the universe was like that. Like the Earth may have been, but I don't think they had the planets and shit, and then the Earth was one of them. They didn't simply just switch places. Like the whole universe was completely different at the time, so you're fucking it up. Anyways,
helped replace the earth with the sun at the center. Galileo made breakthroughs in inertia and motion, and Kepler uncovered stunningly accurate features of planetary orbits.
Neat.
For example, that they were ellipses, not perfect circles.
Cool.
At the time, these were all disconnected thoughts. They had no broader significance. That is until a young man stuck at home because of a plague decided to do something about it. In
I didn't have a smile. He was probably miserable as fuck.
1665, one of the deadliest plagues swept through London, killing up to 100,000 people, nearly 15 to 20.
It was called the Dark COVID.
50% of the city's population. As a precaution, Cambridge decided to shut down, sending students home and halting their studies. One of those students was a young man named Isaac Newton. For the next couple of years, Newton was pretty much stuck at home. But free from exams and lectures, he could pursue whatever.
That's what I am. Basically, it's you're out of what's it called, education and its limitations because you're learning to go down a certain road or a path. And the thing about the refinement is that's your course. That's it. That's your course. The thing about creativity is you need to be able to wander around and go places. You can't do that when you're learning someone's course. A meta head, basically a meathead, AI, intelligent education rather. Right, that's what I call AI, APs, because it's advanced programming, which is just advanced education. Essentially, you're putting in knowledge that existed already. That's all it ever is and or ever was and will be. That's as is until we figure out this life thing. Anyways, yeah, anyways.
Whatever he wanted. And so he did. And what followed is arguably one of the most creative bursts in scientific history. Historians call it Newton's Annus Mirabilis, his years of wonder.
Right, and everybody should go through this. The problem with the world right now is it's becoming too refined. That's the Nazis were, too refined to the point where it was this and that's it. And that's kind of what the system's doing right now. So
during this time, he laid the foundations of calculus, showed that white light was.
By the way, I'm not saying the system fucked up. I'm just saying that for Christianity, for example, the problem was you're building this system, right? And it became something else, and it was still that system, And now you change the leader from I just want to fucking rape the boys and girls to I want to take over the world. And you know what I'm saying? You got you have your army one way or another. So
was made of rainbow, and most importantly for our story, he began connecting
that's the same thing for the army too, by the way.
Galileo's earthly insights with Kepler's heavenly ones. Years later, this would lead to his universal theory of gravity published in the legendary Principia.
No one cares.
And here's that book, Principia. Okay, actually, it's a copy of it, translated in English. But if we go to volume 3,
That's why no one cares, because it's not in the original book, it's not the original blah blah. It's someone made a copy, and that's what it is. Much like the Bible, like there's multiple generations of bullshit. No one knows the original code was. I think it's time to get back to your fucking roots, bitch.
here you can see that he proposes that the planets experience a force towards the sun that drops as 1 over r square. I find it fascinating because this is the copy of the original text that for the very first time wrote it down in the history. Oh my god, that's amazing, right?
Again, he is what you would have is ah, la, 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 basically that excitement, that eagerness. That's what those were essentially. It's just that turn that into hatred and resentment of a certain person. I hate these people. America is the evil, the demons. Ah, la, la.
Anyways, and over here, you can see he proposes that that force must be proportional to their masses.
Cool.
In other words, the law of gravity we all learned in school. And this was radical because for the very first time, we had a single unified rule, a rule that can be applied both to the earth.
Right, but that doesn't mean anything. Again, it's just like we call an apple. Is it an apple? No, it's a little red thing or whatever. But we call it that, and as long as you'll call it that, cool, wonderful. But does it make it so? No.
And the heavens. It didn't just explain orbits or how things fell, but also the tides, predicted the return of Halley's Comet, and a couple of centuries later even helped discover a brand new planet, Neptune.
Not my anus, Uranus.
Purely from the math. But it didn't stop there. As our instruments got sharper and sharper, our cosmic reach got deeper and deeper.
And then someone invaded and what's it called? Broke into that and then implemented this thing called time and acts like it's actually part of the universe, but in reality it was just like a language. Basically it is basically a language, and you act like time is part of the reality or part of the world when it was human made, man made. Like gravity and that shit, it does happen. There's no time involved, nothing to do with time, but somebody broke in and like altered the Bible, for example. You're gonna listen to this orange guy, okay? He's gonna know everything and take his word for everything and trust for everything he says, and then Trump shows up. And you really believe him? Like, do you really believe? Like, that seems kind of, you know what I'm saying?
And Newton's laws passed every single test, from binary stars to galaxies themselves. Every observation just kept confirming Newton's law of gravity. That is until a young man who had already shattered the old ideas of space and time started doing some experiments in his head.
Cool.
That man was Albert Einstein.
Cool.
At first, he found some cracks in the universal law, but as he went deeper, the whole framework shattered.
Right.
But Einstein, why? What made you look at one of the most successful unified model of the universe with so much observational evidence and then say,
it's because you're a scientist, and people trying to turn that kind of like I don't agree into, oh fuck you, I just don't like babies, blah, blah, blah. No, it's just I'm a scientist and you think this and I think that, and that's it. I still have a beer with you, I still hang out with you, you can still be my brother, you know what I'm saying? That doesn't matter, but for some reason, oh, that's right, it's because I divided they fall. Alright.
hey, nope, Newton must be wrong. Gravity is not really a force. It's just a manifestation of four-dimensional space-time curvature. I mean, that's inconceivable.
For the record, there is no fourth dimension. There's no first dimension. There's no second dimension or third. It's man-made. When you understand it like English, for example. In English, then yes, you can say there is the dimensions, but in reality, no.
Achievable. And Einstein says, Mahesh, it's kind of like solving a puzzle, one piece at a time,
Right.
only to eventually realize you've actually learned backend coding, like on boot.dev, the sponsor of this video. If you go to its homepage, boot.dev, I was long in and I think you could decide to payment. Published a series of papers. Happy coding? Back to the video.
Shut up.
In 1905, Einstein published a series of papers that would redefine physics forever. It was Einstein's Annus Mirabilis. One of those led to special relativity. It replaced Newton's old ideas of space and time and predicted that mass is just confined energy, which led the groundwork for particle accelerators, helped understand how stars shine, and helped humanity harness nuclear
Nothing to do with time yet.
power. But there was a problem. Special relativity and Newton's law of gravity were incompatible. But why? Well, Einstein says, according to special relativity, no information can travel faster than light. But Newton's gravity is instantaneous. So if the sun were to disappear, then the gravitational force on Earth would instantly be zero and it would immediately feel the change.
No, that's not true. It would be zero, and that kind of pull, it wouldn't just. It would be like Actually, that's a good question. I gotta break my head. It's kind of like it's exactly the same thing as pulling a rope. And you pull a rope, and it can be a long rope or a short rope. But the second, what happens? I don't even know. Like if you're both pulling a rope and then one person lets go, do you instantly feel it? I think it travels so fast that it basically is almost the same thing as instantaneously. But I think there is like some a change has to be made. It doesn't just go from on to off. It's going from like 100 down to zero, like hella fast, but it's going. You know what I'm saying? That's an interesting thought. But the point is, regardless, it'd be the same thing as a rope. Like you can do that if I had a rope, basically. But yeah, if you have a rope and you make it long enough and you stop pulling, what happens to the other side? So
this violates special relativity. Okay, Einstein, but can't we just modify Newton's laws to fit special relativity?
that's very mathematical of you.
And Einstein says he thought that too until he had the happiest thought of his life, imagining a man falling to his death.
That's a pretty happy thought. Trump. Okay. Well,
Why, Einstein? Why is that the happiest thought of your life? And Einstein says, Mahesh, consider this. When you're in an airplane and that airplane is taking off, it accelerates forward. You feel pressed backwards, right?
wow.
Similarly, when you're in a car taking a turn, you accelerate inwards,
For a while.
but you get thrown outwards, which means every time you accelerate in a particular direction, you feel a jolt in the opposite direction, right?
Right.
And I'm like, yeah, that makes sense. Okay, now
Where does time come into this?
he asks, Mahesh, but what about when you're falling? Because when you're falling, according to Newton, you are accelerating down at 9.8 meters per second square. But Mahesh, do you feel it? Like in the other cases, even here, do you feel a jolt in the opposite direction?
Nope.
I remember skydiving a few years ago in Switzerland. It was honestly pretty amazing experience. But when I jumped, the moment I jumped from the plane, I felt nothing.
Right.
No jolts. Totally weightless for a few seconds until the air started pushing.
Right.
And by the way, this is also the reason why I puked later on because of the zero G. But the point is, no, Einstein, I didn't feel a jolt, so I don't think you feel a jolt when you're falling. And Einstein asks, why not? I mean, you are accelerating down, so why don't you feel an opposite jolt like we feel in the other cases? And I'm like, wait, I know the answer to this. if you go back to the airplane, for example, the seat pushes and accelerates my body first. But my head wants to stay in place due to inertia. Remember, a head at rest tends to stay at rest until my neck pulls it along. So there is a lag. And that's
what I'm saying. If you are pulling a rope, chances are there's a leg behind, like, oh, you let go, like, but
why I feel
that transfer force probably happens at the speed of light. I don't know.
A backward jolt. And the same thing happens with a
My argument is not instantaneous, though.
car. When I take a turn, the friction between my butt and the seat pulls my lower body first towards the center. But my head tends to move in the straight line.
Not towards the center. It's just pulls it towards the car. You're not going anywhere in any direction whatsoever. You're just going with the car. So
Because of its inertia, until my neck starts pulling along with it. And that's why, again, because of that lag, I feel an outward push, an outward jolt.
Right.
And fun fact, this is the reason why F1 drivers have enormous neck muscles. They need it to withstand huge turning forces.
Right.
But, coming back to the point, Einstein, gravity is different.
By the way, I respect the bonus facts. I do that too.
While I'm falling, if I were to drop an
I do it with sayings and such, but yeah.
apple, that apple would fall along with me because gravity accelerates every single thing at the same rate.
The problem here is wind resistance would affect the apple more than it would affect, it would affect the apple more than it would affect you. You eventually will outpace the apple, but simply because of wind. It's like a piece of paper. Like, you can drop a piece of paper, but that paper is not going as fast as you.
Regardless of its mass. Close to Earth, that is about 9.8 meters per second square. So when I'm falling, every single part of my body is accelerated at the exact same time and the same rate, 9.8 meters per second square.
Right, but the pushback will vary. Like, your head will experience 80%, whereas your butt will experience 120% because you got fat ass, and the apple will only experience 40% because it's not heavy enough to push into the last remaining 60%, and so it won't go as fast.
That's why there is no lag, Einstein. And that's why I don't feel an opposite jolt. And that's why I feel weightless. But the acceleration is there. Come on, Einstein. This is high school stuff. But
Not
then
really.
Einstein asks Mahesh, why does the force of gravity accelerate everything at the same rate, regardless of its mass or material or anything? And I'm like, because of Newton's second law. The net force acting on my body while I'm falling is the force of gravity. And that equals, according to Newton's second law, mass times my acceleration. So look, my mass cancels out, and as a result, the acceleration due to gravity is independent of the mass of the falling body. And Einstein says,
Technically, yes, but truthfully, no.
this is the crux of the problem, Mahesh. This mass, let's call it your gravitational charge because it decides how much gravity you feel. And this mass, let's call it your inertial mass because it decides how much inertia you have, how much you resist acceleration. These two are completely independent and different quantities altogether. And yet, for some reason, they happen to be the same. Why? That's not how other forces work. For example, how much electric force you feel depends upon how much charge you have, which is very different from your inertia. How much magnetic force you feel depends on something called your spin. Again, very different from inertia. And that's how, all other forces are. For every other force, there's a different kind of charge that decides how much force you feel. And yet for gravity, that charge, gravitational charge, just happens to be your inertial mass. Why? Isn't that a little suspicious?
I don't know what you're talking about.
And I'm like, wow, Einstein. They say that science is about asking the right questions, and this is at its best. And this is why I love to understand the thinking process rather than the facts themselves. So this is amazing. Anyways, Einstein
I don't know.
is still waiting for an answer. And so I'm like, maybe that's just how it is. Maybe there is no deeper explanation for that.
You need to dumb it down, basically.
And Einstein says, Mahesh, Let's find a deeper explanation for that. Okay, what do we know so far? When you're falling, you don't feel your acceleration. In fact, if you were to close your eyes, you wouldn't know if you're falling on Earth or you are in some deep intergalactic space just floating over there.
That's not true. The wind would let you know pretty fucking fast.
And if you had an accelerometer with you, it wouldn't even detect any acceleration. Okay. Now, instead of coming up with some convoluted explanation like your gravitational charge just happens to be the same as inertial mass, and that's why you don't feel it, but it's there. Why don't we come up with the most straightforward answer? If you don't feel your acceleration and you can't detect it, maybe it's not there.
But you can. And you can detect it, and you can measure it, and we kind of do know, like, that's as fast as you fall, based on, what's it called? They call it the constant, because if the wind wasn't there, you'd actually go faster. But there is no mention of this because you're small-minded, and you need to shut up and listen and stop talking like you know when you don't.
Which means maybe when you're falling, you're not accelerating at all. And I'm like, hello, there's gravitational force pulling on me. And Einstein said, okay, maybe there is no force of gravity. And I'm like, wait, there is no force of gravity acting on me. I'm just floating there. Then why do I hit the ground? And Einstein's like, maybe you don't hit the ground. Maybe it's the ground that's accelerating up at 9.8 meters per second square and it hits you. At first, I'm like, come on, Einstein, that's crazy. And Einstein says, maybe so, but it answers our nagging question. Because it's the ground that's really accelerating up at 9.8 meters per second square, from the point of view of the ground, someone standing on the ground, it gives you the illusion that gravity accelerates everything down at 9.8 meters per second square. Isn't that a much simpler explanation, Mahesh? So this is where the whole gravity must be.
But again, that's excluding the whole detail of Earth, oxygen, air, wind resistance, your clothing, your fatness, your thickness, whatever. There's wind resistance, wind drag. It was cold that day, so the air's thicker than if it was hot, and the air was thinner. You know what I'm saying?
An illusion, perspective comes from. And this reminds me of something called the Occam's razor, which says often when you're trying to solve a problem, the simplest explanation is the best. And again, you can see that's what Einstein is doing over here. But wait a second, Einstein. If there is no such thing as
that, I've heard it before, by the way. I just don't think about it very often, but it seems stupid and it's very context based.
Gravity, it's all an illusion. Why am I feeling my weight right now? Because Mahesh, the ground and the chair that you're sitting on right now, that's accelerating you up at 9.8 meters per second square. And just like in the airplane, when you were accelerated forward, you felt an opposite jolt due to the lag and inertia. Right now, because you're being accelerated up due to your inertia, you're feeling a downward jolt. And that downward jolt is what makes you feel like you have weight. There is no real force of gravity. What you feel as gravity is just inertia. And this is why the gravitational charge in the Newton's formula of gravity just happens to be your inertial mass. Because there was no gravity. What you've been feeling all along is just your inertia. It's no different than the opposite jolt you feel when your airplane is taking off.
The whole discovery process, it's kind of like, oh my god, it turns out I'm gay. Like, that's kind of reminds me of, honestly. Because, all you're doing is changing words around, and you're like, wow, amazing. It's like, okay.
It's the same thing. It's just that the jolt is downwards, and that makes you feel like you have weight. That is insane. That is crazy. So, just to be clear, Newton says the ground is inertial, not accelerating, and it's the falling things that are accelerating. But Einstein says, nope, it's the falling things that are inertial, not accelerating. It's the ground that's accelerating upwards, making everything stick to the ground.
That could potentially be true, by the way. We are on a planet traveling through space, and we do have a spin about the planet, so God knows.
But wait a second, both models seem plausible. How do we know who's right?
We don't. Realistically, we don't.
Well, we need an experiment to tell them apart, and there isn't any. So both points of view are equally valid.
Right. Just like
And therefore, Einstein calls it the equivalence principle. So his big claim is that being in an accelerated frame is indistinguishable from being in a gravitational field. This seems to be an extension to Galileo's relativity. Galileo figured out that rest and constant velocity motions are the same thing, looked from different points of view. Now, Einstein takes it to the next step and says maybe acceleration and gravity are also the same thing, just two different points of view. So he's trying to generalize things. But hang on, Einstein, your equivalence principle has a big problem. First of all, Earth is round. So if the ground is accelerating up in all the directions, shouldn't the Earth be expanding?
no.
But there's another issue. Falling things also stretch and squeeze. It's just that for small things, we don't notice it. But if there was something huge like an asteroid hurling towards the Earth, it would stretch significantly. Sometimes it can even tear the asteroid apart. And it's not just the asteroids. Even the Earth and Moon fall towards each other, and they're pretty big, so they too significantly stretch and squeeze. And on Earth, this effect is what gives rise to tides. That's why we call this effect the tidal effect.
That's also why we have what's called satellites and whatnot, and why we need to boost them every now and again. Like again, you're just all you're saying is, "Wow, this is cool." But you're not really saying anything, and there's no substance to talk to or argue about.
Newton's model, where you consider gravity as a physical force, can explain this beautifully. Gravity gets stronger closer to the Earth. So if you've got a big object like an asteroid, this part feels slightly stronger pull compared to this one. So this part accelerates more than the part behind, and look, that's what stretches the asteroid.
But when the front gets pulled, the back comes with it. And so there might be a kind of yanking or whatever, but at the same time, like, depending on the strength, I guess, of the asteroid, it all gets pulled, basically.
And the math works out, and it nails the explanation for tides. But Einstein, you say there is no such thing as gravitational force. According to you, this asteroid is just floating, absolutely no forces acting on any parts of it, no accelerations at all. So how do you explain the stretching? You can't explain the tidal forces, buddy. Your equivalence principle breaks. What you got to say about that? And Einstein says, yeah, Mahesh, you're right. This means that the equivalence principle is only valid locally, in small regions where gravity can be assumed to be uniform. But in large regions where the gravitational field varies, it cannot explain the tidal effects.
And for the record, it's not really him asking these questions, it's him stealing the thunder from somebody else and putting his name there, and he's acting like he's the one who asked the questions when somebody else did. Again, it's a very common phenomenon for people that exists today. I call it false alpha or reporters, and so forth.
And so I struggled with this problem for nearly 5 years, but then I had
Wow.
a breakthrough. I found a way to explain how an asteroid can stretch even without any forces acting on it. How? How is that even possible, Einstein? And Einstein says, Mahesh, first let's bring this problem into my territory. Let's draw a space-time diagram for that. Now,
Okay. Now, I don't know if Einstein did this or not. No one can say if it's just a name that they use, or if he actually means that time is an actual thing, or if it's just Like an inch, it's a measurement, and you can use it as a way to measure something, but it doesn't actually exist outside of that use. You know what I'm saying?
A quick refresher. If a small rock is at rest in space, it's still moving in time, so its graph is straight.
Again, time isn't real, but as far as like for example 1, 2, and 3D, they aren't real, but we say they are. And as far as it's kind of like a computer dragon, like it's not real, but you can fight it and defeat it because we're making it real, but it's not a real dragon. You know what I'm saying? There is no actual dragon, but there is a dragon and you can't kill it.
And vertical. We call this the rock's whirl line. If the rock's moving at a constant velocity, it's still straight but tilted. So look, inertial motion always give you straight whirl lines. But if the rock accelerates, that whirl line curves. More the acceleration, more curved the whirl lines. So remember, in space-time, straight whirl lines are inertial, non-accelerated.
But what are the divisions? Is that just frame rate? Because you need up your frame rate if that's the case. Because it should be just smooth. Because there is no frame rate in life. It is. Like my hand is not just displacing and then just kind of randomly popping out and then in of existence. It's literally going from here to here, and it fills every place in between those 2 points that I chose out of nowhere. My hand was literally between them, and so yeah, the frames argument is stupid, man. Go ahead.
And curved whirl lines are accelerating.
But yeah,
Okay, now according to Newton, we can consider the ground to be inertial. Let's assume it to be at rest. And the falling person is accelerating towards the ground, so their whirl line curves. But in Einstein's model, the falling person is inertial, say at rest. So their whirl line is straight, and it's the ground that's accelerating up. So far, so good. But what if a big asteroid is falling? In Newton's model, the front of the asteroid being closer feels stronger gravity. So its whirl line curves more than the back. That's why it stretches. This is the tidal force. And we know this is a fact, so the same thing must happen in Einstein's model as well. Somehow, these points on the asteroid must also move farther apart. But
what stretching though? The appearance is not the of. You know what I'm saying? It looks like it's stretching, doesn't mean it actually is stretching. That's just your frame rate. Oh, 1 second. I thought I was being too loud or something, but it turns out I was just being gifted. Oh yeah. I've been trying to keep it down though. Alright, sorry about that. Continue.
But wait, Einstein, according to you, that asteroid is inertial. There are no forces acting on it, which means I can assume that all the parts of that asteroid are at rest. So the world lines of these 2 points should be vertical and parallel. There should be no curves, no acceleration.
Right.
And yet, somehow the asteroid should stretch, meaning the distance between these vertical parallel lines should increase. How can the distance between parallel lines, straight lines, increase without curving? That's impossible, Einstein. And Einstein says, Mahesh, that's not the attitude we have over here. Don't say it's impossible. If you want to have breakthroughs, instead ask, how can I make this possible? And I'm like, okay, how can we make parallel straight lines move farther apart without curving them? How is that? How can we make that possible? And Einstein says, what if we drew them on a globe? Imagine 2 people walking north from the equator along the lines of longitude. They start off parallel and they're walking as straight as possible. No turning, no curving. And yet they slowly move closer together. Why? Because the surface itself is curved. On curved surfaces, look, straight paths can come closer. Now, if the surface was like a saddle,
No. They look like it.
then the straight parallel
Literally, they're not. Because, like, you're going in a straight line. And if you're curving, then you're not going in a straight line. You know what I mean? It's hard to explain. But, literally, science should not be what's called decided by limited data, which is what it is today. Basically, apparently, you limit yourself or limit what you're told or limit your education, and you go so far and then just kind of fuck it, whatever, fine, whatever. And that's what education is. And what I'm trying to say is that we know more, so let's find out more. But the problem is, we live in a world of gammas, and everyone's afraid to fucking step on anyone else's feels because of getting banned or whatever. So we get stuck in, and to just repeat, we're stuck on repeat. Like the next song, please. You know,
paths could also drift apart. And I'm like, wait. These are not straight lines, Einstein. These are curves. I mean, the line of longitude is a part of a circle.
right.
So this doesn't apply over here, right? And Einstein asks Mahesh, what's your definition of a straight line? And I'm like, well, it's the shortest path between 2 points. And Einstein says, well, a line of longitude is a shortest path between, say, the 2 poles of the Earth. So it fits the definition of straight line. Now, to avoid this,
right. But it fits, but you're still measuring it like you. What you're doing is conflating the straight line of this and of this. Understand that that's straight line of this. That's not the straight line of this, right? And that's the difference. That's the difference. You can make it work on this, and you might be stupid enough to believe or whatever, but that's it, right? It may be a straight line to that, but that is not that. So
this confusion with this whole straight terminology, the shortest path between any 2 points is in general called a geodesic. Okay, so long story short, on a flat piece of paper, if you draw 2 parallel geodesics, they will have to stay equidistant. But on a curved surface, parallel geodesics can converge or diverge or do whatever they want.
right, but on a curved surface.
So coming back, every tiny part of this asteroid, including these front and back pieces, are inertial, right?
No.
If we assume it to be at rest, then their paths through spacetime must be straight, geodesic, and parallel, right? Now, we know the asteroid stretches. So I want these paths to move away, but still stay a geodesic. There is only one way that can happen.
Change your logic. That's what you're doing.
if the underlying space-time itself is curved. Then,
There is no curve.
like on a saddle, paddle geodesics
It appears that way. It looks that way. But if you actually magnetize or zoom in, or if you turn your frame rate up to 1 billion, you will see that it didn't change shape, basically. And if it did curve, it would explode.
can diverge.
If it did stretch, rather, it would explode.
This is how we can explain the asteroid stretching, even though there are no external forces acting on it.
Nope.
It stretches because even though there are no forces, these inertial world lines are on a curved space-time, drifting apart, making the asteroid stretch.
No.
This is how Einstein concludes
It looks like it stretches. It's not stretching.
by analyzing the tidal forces that our space-time must be curved. Isn't
No. Space time isn't curved. There's no such thing.
that amazing? I mean, oh my god. This is how it happens. Einstein, this is amazing. But I still want
That's how you explained what can't be explained, because a straight line is not I'm sorry. Yeah, a straight line can't exist on a curved surface unless you take a curved surface and you put a straight line through it. But then you go into the planet and whatever. Can't happen.
want to circle back to the question that I asked earlier. If the ground is accelerating up, shouldn't the Earth expand over time? And Einstein says, all right, let's draw a space-time diagram one more time. Without any mass, space-time is flat. That means two paddle geodesics, like the world lines of these two apples at rest, for example, will stay parallel. So the distance between them stays constant. What happens when we add the Earth? Now, in Newton's model, space-time still stays flat.
Of course. Real quick. As far as math goes, yeah, you can work with it. You can say there's 4Ds. You can say that time exists, and you can have all this bullshit. But understand that in reality, there's no time. That's a man-made instrument that we use. Beyond that, there's no such thing. Every day is a day. It's one day. In fact, the day is a lie, because there is no days. There's only the rotation of the sun. It's going around our planet. It looks like days, right? There are certain places on this earth you can go and you have a day for a week, right? Or it never is nighttime or whatever. Like, it depends. But the point is, I don't know like the exact, but there's 3 days that'll go by, and somehow that's accounted for, right? And that's my point. Because time has been made, we're allowed to do things. Like, it's like a language. That's fine as far as that goes. But that's it. There isn't an actual 4D creature. In your mathematical theory world of fandom or pretend, sure, whatever. But the point is, who fucking cares? Like, if you want, yes, go ahead, scratch your asshole. Great, wonderful. Have fun. If that's your thing, go for it. But stop trying to drag other people into it by saying it's part of reality or it's part of life, because it isn't. And we've seen what happens when I'm quiet. When I've had my gloves on, when I had pillows on my hands, I couldn't do anything. I couldn't say anything. I recently, like a few months ago, took them off, basically, because I'm actually getting the medication I need. Yeah, I just want to make sure I did take them. But yeah.
The Earth pulls on the apples, curving their world lines inward.
Nope.
So look, the apples deviate from their straight inertial paths. They accelerate. That's gravity as a force. But in Einstein's model,
Again, in mathematics, whatever. You want to draw a Nixon in there? Go for it. You can, whatever. In reality, no.
there is no force. Instead, the Earth curves space-time itself.
Nope.
So these paddle geodesics don't stay paddle, they converge. The apples are now just following their inertial paths, straight lines in curved spacetime. On the diagram, those paths look curved, but they're not accelerating. That curvature is just what straight looks like in curved spacetime.
Yeah, we're using graph paper that's curved. So the straight line is curved. But in reality, that's not the case.
Now, zoom out and look at the opposite ends of the Earth,
Time is real, ladies and gentlemen.
Mahesh. Their geodesics should also curve inwards because spacetime is curved.
No,
So if these two pieces of Earth were inertial,
space-time as a measurement, as in inches and feet and a meter, sure. But as far as like reality goes, no.
they too would move towards the
For
center.
example, you won't walk up to a caveman and be, hey, move that rock a meter. But, huh? Right? What the fuck you talking about? Basically, that's what they would do. But if you said, hey, move that rock about, that far, they'd be like, and they do that. You know why? Because it's not the same as a meter. It's a measurement. We made it, just like time. Being a measurement, we made it. That's why.
But they can't because the Earth's matter below resists it. So it constantly pushes them outwards, accelerating them away from their inertial geodesic.
Oh, yeah.
So on the diagram, these world lines look straight, but they're accelerating. That straight line is just what an accelerated path looks like, again, when the spacetime itself is curved. So look, Mahesh, in curved spacetime, Earth's surface must be in a constant outward acceleration just to maintain its shape. Otherwise, it would collapse inwards. By the way, it's similar on the globe. If these two now want to maintain a constant distance between them, they have to move away from their geodesics. So look, they have to keep moving away from each other just to maintain their distance. And this kind of makes sense, right? Because the curvature naturally tends to bring them closer. So if they don't want to come closer, they have to move away from each other. Similarly, the ends of the Earth have to be accelerating away from each other, outwards, just to maintain the shape in the curved spacetime. And because of that outward acceleration, people on the Earth feel their weight due to their inertia. So can we now summarize Einstein's thinking process that led him to this whole idea of curved spacetime?
I know for a fact that Einstein would agree with me. He'd be like, yeah, I know. Time is a real word about it. I have to say this because for some reason there are idiots that think an inch is real. Like he would be like, no, inch isn't real. What the hell? I know, but there are people that for some reason they think it is. Yeah.
Time. First, freely falling objects all accelerate at the same rate, regardless of their mass. He finds that very suspicious. He doesn't accept the whole gravitational charge just happens to be the same as inertial mass. He says, let's keep it simple. Since falling folks don't feel or measure any acceleration, he claims that falling can be treated to be inertial, and gravity is just equivalent to acceleration. And as a result, he concludes that gravity must not be a real force, it's just an illusion. But that doesn't explain why falling objects get stretched. So the next crucial step is he rephrases that problem using geometry.
Like the whole time spaceships and proof of time and time dilation, whatever. Like that's just all that is your method of tools failed. Basically, that's it. It's not because time actually changed. It's because your tools couldn't keep up. And you're using outdated tools. If you put a digital clock in there that didn't have a thing that was based off of gravity, for example, measuring, then you wouldn't see it anymore. That wouldn't happen. Basically, that's my point. The only reason why it popped up is because they need for you to believe that. They need you to believe that, and if you don't believe that, then the whole system, their control, their hierarchy, their domination, they own you through that, and that's why they need it because they own it. So when um, it's kind of like the oil um, franchise. If you have a car that runs off of the sun, you stop buying gasoline. Basically, we can't have that. We need you to buy gasoline. So how about a hybrid? So we'll reduce our sales by half, but it's better than reducing our sales by null, becoming zero purchase power. We prefer to have some purchase power like that. No, okay, sure, whatever. But I'm just saying, like, that's basically what's happening here.
He realizes that asking how can a floating object with no forces on them stretch is the same as asking how can parallel straight lines move away without curving.
They cannot.
I find that a stroke of genius because that he rephrased the problem, in,
Yeah.
in terms of geometry, a physical problem in terms of geometry. That's amazing.
No. He was like, what if your straight line was a circle? And that's why it was a circle. And you're like, wow, that's so cool. I'm like, oh, okay.
Amazing, if you ask me. And finally, he connects all the dots and realizes on curved surfaces, parallel lines can drift apart without curving themselves. And so the same thing must be happening over here, and that's how he explains the tidal forces by saying space-time itself must be curved.
Nope.
We just rediscovered the step-by-step thinking process that planted the seeds for general relativity. But this is just the tip of the iceberg. I mean, Einstein got stuck again. So let me know if you want to dig deeper. There is so much more to rediscover over here.
Now, if you want to get brain rotted, if you don't believe in the system, do you guys want to learn about the metrics of a foot and a mile and an inch? Or do you want to learn about meters and what they have, right? There's a battle between those two. It's the same thing, but there's a battle. Divided they fall, bitch. I don't care. Personally, I don't care. If you didn't care, then you wouldn't have that division, and then they wouldn't have that army that they need. So that's why they shut me down. Anyways, it's up to you, as Captain Planet would say, to prevent evil dictatorship rule. Anyways, peace. I'm hungry, so hello. Something like that.